Hi everyone, and welcome to another tutorial of the TaskGen tutorial series. So today we'll be covering a very important tutorial called hierarchical agents. And this means it's focusing on this loop where the meta agent has inner agents as its functions. And this inner agent can feel free to do things in an agentic manner and then report back what has been done to the meta agent. Okay, why do we need such an inner agent? It's because there are some things that one simple function call may not be able to handle. Like for example, if you want to book a website or if you want to, navigate to a browser and so on, like this may be something difficult for one function and you might need an agentic approach where, you receive environment feedback and adjust your actions accordingly. And that's why we have an inner agent. And some people will ask, why not do everything at the meta agent level? This will actually lead to cognitive overload. So we try to, split the task into manageable bite-sized portions. And that's why this kind of hierarchical structure is actually quite useful. So the next question is, how much information should your agents know? So I believe the inner agent needs to know the context of the meta agent so that it's better able to facilitate its actions in line with the context of what has been done before. Okay, however, the meta agent may not need to know everything of what the inner agent does. This is because the inner agent might be dealing with the details. And the meta agent is like the boss. The boss need not know all the details of the operation, just the broad ones that can help the boss do its further decision planning. So the information flows quite well downwards to the inner agent, but only a summarized version will be flowed back to the meta agent. So let's see how this is coded out. You can take a look yourself at tutorial 4. So basically, we set up TaskGen, install TaskGen, import required functions, set up API keys if needed, define your own LLM, and so on. So now I'm going to go to how to create the inner agents. And the process is very simple. So you look at the first part here. This creates an agent, a menu creator, creates a menu for a restaurant. And this basically is your meta agent. So no different from like how we have done it in tutorial 1 for the agents, only that the functions that we give these agents are now fellow agents. Look at this, the agent list here. We have chef, we have boss, we have creative writer, we have economist, and all this can take in different functions as well. These are like really just an agent. So it's like a stack agent, an agent within an agent. Quite cool, right? Yep. So there's also things that you can configure, like how many subtasks you want it to do, like max subtasks over here. Like creative writer, we limit to 1 so that it doesn't like keep generating things. So there are a lot of things that you can do here. Back end, what happens is that we will convert this agent to a function. We'll wrap it inside a function. We'll call that agent, pass it the instruction. The agent will run its stuff, and then it will reply back by the reply user method, reply back the main agent to tell the main agent what has happened. So now you can see we just assign the agents here with the assign agents function. So let's do the, first we give some stuff. Now let's implement it. Like here, this will give you a number given a string. This will give like a random price based on a string. And we can see that if we do it in the dish price function, and given a list of dish names, like for example, spaghetti and tomato, we will get the prices. Okay, over here, if you want to like make it production wise, you could put like a vector DB here so that you return the exact price for the ingredient. All right, so we have defined our meta agent as described above, the agent list, and assigned the agents, and let's run it. So there are 2 methods we can use to run. This first method is the recommended one. Basically, we let the agent handle all the calls to the other agents. So we just run this task, generate 5 menu items, and output in manual format. So let's see what it does. And okay, so first it decides to use the creative writer to generate interesting dish names and descriptions. And you can see the creative writer does some generation. And then what it's going to do now is going to reply back the main agent. So you can see this, the reply. This is like the summarized reply. If there's a lot of tasks being done here, this would be the summary. All right. So the end of inner agent is done. Next, we need to ask the chef to come up with ingredients. So over here, the chef not only will have this instruction, the chef will also have the earlier context of what has happened in the subtask completed of the meta agent. And the chef would also have the access to the context of the meta agent. So a lot of parameters are being passed into the inner agents so that there's better decision-making abilities using this kind of information. So we have the chef generates the ingredients and replies back to the main the main agent. So you can see this is very similar to what has been generated up here because it just needs to reply this ingredients, which is exactly what it has done here. All right, so we have other things like the economist will generate the prices, and you see it replies back in a concise format. All right, and we have ended the task. We can see what has been done in the status. These are the subtasks, and you can see the function name as well as the instruction for each of the subtasks as well as its outputs. If you are a very you like to tinker around with how things are done, you can try myagent.thoughts, and you can see the observations, thoughts, subtask, equip function name, and inputs for each of the steps that the meta agent has done. So this is pretty cool. If you like to, output to the user what are the thoughts for each agent and so on, you can use this method as well. And now we go to the reply user. This will basically tell the user what has this agent done for you. So based on the list of subtasks completed that you saw earlier, it generates out the menu items, the menu names, description, ingredients, and pricing, exactly as what you wanted it to do. So that's pretty cool. Okay, so this works out quite well because this is a constrained example. So if let's say your use case is a little more complex and like using the agent itself may not get you the desired outcome all the time because sometimes it is not as robust as generating the pipeline. Sometimes you might want to just step through the process yourself, do a pipeline method, and call individual agents one by one. So you can do that using the use agent method. Okay, so let's see how to do it. We first use the same agent. We assign a task. So instead of run, we assign a task. And then instead of getting the meta agent to choose the inner agents to use, we define it ourselves. We say, hey, use creative writer. This is your instruction. And let's just run this and see what happens. So you can see that we are running it now. We generate the 5 Italian dish names. Very good. Now we see the status of the agent, and you can see that it's as though the meta agent has decided this for itself. All right, and then now we ask the chef to generate the ingredients. So you can see this is like you manually stepping through the agents yourself. The alternative to doing this is if you use a strict JSON call to give all the context needed for each process and ask the strict JSON call to output a certain thing that you want, like for example, ingredients and so on. You can also do that. In fact, it might be even more accurate because you define your output format. But for more complicated things, sometimes you don't know the output format. So this is like an in-between. Like you can manually use your inner agents, and have the same kind of functionality as though you have the meta agent, just that you have more control over the process yourself. So you can see next we have the economist to generate the prices. Then we have now we have something different. We have the boss to say, hey, what 3 dishes should we serve to Gordon Ramsay? And the boss replies this 3. And basically what happens is the boss will need to prepare the final presentation document, and this is the output. Okay, so the LM is okay. That okay over here. That's why sometimes we want to limit because sometimes it keeps generating more and more details. Okay, we might want to cap it somewhere, so you might want to say, hey, max subtask is 2 or something. So you can see after iteration, this is the final output for why they selected these 3 dishes for Gordon Ramsay. Let's reply the user the 3 menu items in the menu format. Okay, so you can see this is what we have. So the prices $9, $8, $7 is all gotten from the above here. If you scroll back, $9, $8, $7. So all this, it maintains the previous context. So it's pretty cool. You can see what's the agent status now, and all this subtasks is as though the meta agent selected this agents directly. So if you go to tutorial 1, you can also do the same thing for functions by saying use function. All right, but this is when the function is an agent, you can say use agent. All right, so we can even say that, hey, what you want to do is you can summarize the subtask history. Okay, instead of saying that, hey, I have all the subtasks above, maybe I just want to summarize what has been done in this task, like generate the 3 Italian dishes. You can summarize the subtask, so if you can make the subtask more condensed, and you can see after we summarize, we only have 1 subtask remaining in the subtask completed. This is very useful. You can call this summarize subtask completed. Every time you have too long context in your subtask completed, you can condense it into something much more summarized. And this is actually automatically done for you every 5 subtasks. So every 5 subtasks, you can have the TaskGen will automatically summarize the subtasks based on your tasks. Okay, you can also override this using the subtasks, the summarize subtask count. Okay, there's one variable for that in the agent. So now we can see after we summarize, this is the result. We can then remove the last subtask if we want to. So I also provide utility functions to remove something like this. So after you remove the last subtask, you can see that the agent has nothing. Okay, so apart from just removing the last subtask like that, you can also, because your agent is having everything in subtask completed, you can just remove the dictionary key yourself if you want to just remove any subtasks that you like. All right, so this is a bit more of the, you want more control over your agent. These are some techniques you can use. So next, I'll go to the warehouse example. This is an extension of tutorial 1. Instead of only having one factory manager now, we have 2 factory managers, one for factory A and one for factory B with 2 separate inventories. So you can see this is add and remove inventory for factory A. Over here is add and remove for factory B. And we have the agents here. We basically give each agent a global context of the inventory. And this inventory here all comes from the shared variables from the meta agent. All right, so when you call your inner agents, you will pass on all the shared variables at the meta level to your inner agents. So, you can just define it here. And here we have global context to just, retrieve the shared variables. Okay, so inventory B and inventory A here. And the global context for the main agent will be both inventories. Okay, why do we want to do like this? I mean, you could also have one agent to handle everything, but there might be cognitive overload. Here, if your main agent just, transfers the managing of inventory A to agent A and the managing of inventory B to agent B, it helps to offload the processes quite a lot and you get better reliability. So you can see these are the functions. Here, the factory A inventory manager, which is your inner agent, is actually something like a function to the meta agent. So this is the agent description and executes instruction. All right, so let's run this. We just want to add apples to factory A and pears to factory B, and let's see what happens. So the meta agent calls factory A manager, and they add apples, and they reply, okay, I've already added the apples, all right? And then the factory meta agent now says, hey, factory B manager, add pears to your factory. And you can see that the reply is, hey, I've added, all right? And the task has ended. We can see the shared variables has been updated accordingly. So cool. Now let's try to do something else, like remove the apples from factory A and add bananas and kiwi. So let's see what happens. And here we basically have the factory A inventory manager being called to remove apples. Okay, after removing, the factory A manager reports back up. Apples were successfully removed. All right. So after that, add bananas and kiwi. Factory A manager then adds in the bananas, adds in the kiwis, and then now reply back. Yes, I've added in the apples and the bananas and kiwis, and we can end the task now. So we can see the shared variables now. Inventory A has bananas and kiwis. Inventory B has pears. Exactly what we wanted. Seeing the status, you can see these are the subtasks completed, and you can see that in general, like add pears, add apples, remove apples, add bananas and kiwi. All these are done by calling the inner agents to do it, and the meta agent is like the coordinator to do all this. So it's pretty cool, right? Yeah. And that's about it for the tutorial. So this tutorial 4 on hierarchical agents is quite important if you scale up, your agentic system to something bigger and you need some inner agents to do more complex things. So again, if you have any feedback or if you try this out and you want certain features in, do let me know. And we will try our best to incorporate this. This is a framework that will be continually improved, and I hope you enjoy it. And with that, signing out.